Okay, so if you guys are seeing this right now, I wasn't able to be here today. These are the 6 problems that we're going to talk about today in class. Hopefully you got a worksheet from the sub. It looks just like this. If you're looking at this on a different year, feel free to just copy these problems down right now, and we're going to go over this. So again, for your notes, this is chapter P unit or lesson P7 for Precalculus, Precalc A. This happens to be a 2019 video. Okay, so we're going to look at this problem right over here first. If you haven't noticed from the picture, we're looking at a lot of inequalities. So 2x plus 4 is less than or equal to 5. We kind of did some of these inequalities or equalities for absolute value a couple days ago. We're going to have this. We're going to have 2x plus 4 is less than or equal to 5. But we're also going to have 2x plus 4 is greater than or equal to negative 5 in this case. So anytime you have an absolute value, you know that inside of here can be both positive or negative. And if it was going to be a negative, then you know we got to switch the sign. So go in here, subtract 4, and I get 2. X is less than or equal to 1, and x is less than or equal to 1/2. Go in here, subtract 4, and I get 2x is greater than or equal to negative 9, and x is greater than or equal to negative 4.5. Well, if we know that we have these two things, boundaries on our number lines, negative 4.5, I'm going to go ahead and put right here. We can put 0 right in here, and that means 1/2 isn't much further than that. We can do 1/2 here. And this says that x is less than 1/2 and x is greater than negative 4.5. Both of those happen to have dashes underneath, so it's equals to. So we'll go ahead and do solid circles and connect everything in between those two. Okay? So that's what the inequality would look like. And remember, this is called graphical notation. We could also write it like this. 1/2 is, or actually let's start with the smaller number. Negative 4.5 is less than or equal to x is less than or equal to 1/2. And if we did it in terms of interval notation, we'd put negative 4.5 comma 1/2. And both of those would get brackets because it could be equal to at that point. Okay. Let's do the next one right here. The absolute value, and then you got a fraction. Same thing again. We got x minus 3 is over 5 is greater than or equal to 2, and we have x minus 3 over 5 is less than or equal to negative 2. So again, flip the signs and change it to a negative. So here we go. We get x minus 3 is greater than or equal to 10, and x is greater than or equal to 13. This one right here, x minus 3 is less than or equal to negative 10, and you add 3, and x is less than or equal to negative 7. In this case, you can see that these things are going opposite directions. So if I do my quick little number line, I get a negative 7 here, solid circle, I get a 13 here, solid circle, but according to my thing, it's going this way here and this way here. Awesome. So in terms of excuse me. In terms of how to write this, if I was going to do an interval notation, it would look like this: parentheses, negative infinity, comma, negative 7, bracket, and we do a little u, which means union. It also includes this section, bracket, 13, comma, positive infinity. Looks just like that. Okay? And we can't put these two together in terms of one common thing for algebraic, because again, you can see they go opposite directions. So that's what it looks like if you're dealing with absolute values. We got one that goes together, one that goes apart. Just make sure you flip the sign and change what the number is. If there's anything else that's with these things, with these problems, like maybe there was a 4 plus 3 times this whole thing in the very beginning, I hope you remember, we have to move the 4 first, so we'd subtract 4 to the other side, and then we divide by the 3, and it's only at that point that we'd have to do these things. So we have to isolate the absolute value symbol. So move everything before you start doing any of your work on it. Oops, sorry, that was not in the thing. So again, if there was other stuff, this was a big if, I just made this stuff up. If there were other things that added to or multiplied to the absolute value symbols, we have to move those first before we do our 2 little breakups. Okay. So now we've got some absolute values are gone, and we've moved on to this one happens to be a quadratic, this one happens to be a cubic, and we're going to go ahead and see if we can break these down. So if this says 2x squared plus 19x plus 24 is less than or equal to 0, we know that the parabola could possibly look like this, hopefully. Since it opens up, could possibly look something like that. That would mean that this entire section right here is all below the x-axis, or less than or equal to 0. So we'd want to know the range from here to here on it. Now, I don't know exactly where it is, but I'm going to do some factoring to find out where the x-intercepts are to help me out with that. And you guys know, and I chose this one on purpose, that we know we have a possibility of 2x and x. So we have to take a look at that leading coefficient. A lot of factors of 24, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Because both signs are positive, both of these things have to be positives. We need things to add together to equal 19. This is a 25, a 14, an 11, and a 10. None of those do. But remember, one of these columns, either this column or this column, is going to be doubled. And I think this will work out for you if I go all the way down to here. If I double the 8, I get 16. I have to multiply the 3 by 1, 17, 18, 19. That gets me a center of 19. So that's what it has to be. So the 2 had to multiply the 8, and the 3 goes there. So I got 2x plus 3 and x plus 8. Now, this gives me negative 3 halves, and this gives me negative 8. I'm going to come down here to my number line. Or actually, I'm going to kind of put this number line right on an axis system. So negative 8's way over here, and negative 3 halves is right here. And since we know that those are the places it crosses the x-axis, and it's a parabola that opens up because it's positive, my parabola has to go like this. So then if I want to know where is it less than or equal to 0, I know it's less than or equal to 0 from here all the way to there. So what do? I write negative 8, brackets, comma, negative 3 halves, brackets. Those are all the places that it's less than or equal to 0 because of the fact that the parabola is below the axis at that point. Okay, so this next one's a little bit more complicated. X cubed minus 25x is greater than or equal to 0. So the first thing I'm going to try and do is I'm going to try and factor this. So hopefully you realize that I can pull an x out, and I get x squared minus 25. Awesome. And ooh, hey, that's a difference of squares. So perfect square, subtraction sign. So now I know I have the factors of an x, and an x minus 5, and an x plus 5. Well, cubic functions kind of do stuff like that. So I know, because it crosses the x-axis at the place that is equal to 0 for this, this, and this, let's go ahead and draw my axis system out. I know it crosses right here, I know it crosses right here at 5, and I know it crosses right here at negative 5. Now, because this is a positive x cubed, I know that this branch has to go up, and this branch right here has to go down, because let's say you took 10,000 and you cubed 10,000. Well, 10,000 cubed is a giant positive number, so that means anything that's going to the right here has to be going up. So from 5 has to go up. I know it doesn't bend back down again because of the fact it doesn't have any other x-intercepts. Okay, hopefully everybody's okay with that. Which means, and I honestly don't care what this does here, but it has to do something like this in the middle. But again, I don't care how far down it goes or how far up it goes. I just want to know where it's less than or equal to 0. Nope, sorry. I want to know where it's greater than or equal to 0. So to me, it looks like all of this section right in here is greater than or equal to 0, and everything here to infinity is greater than or equal to 0. So my solution for this would be -5 brackets, comma 0 brackets, because it could be equal to. So all of that range, union, and then also it's greater than or equal to 0 from 5 to infinity. So 5 brackets, comma infinity. And I got to put a curved thing on the back end of that because of the fact that that doesn't that doesn't go on and have an actual stopping point. If we put a bracket on infinity, that would say, hey, that's the end of it, but you know that it goes forever. Okay, so this one right here, 3x cubed plus 4x squared minus 7x minus 3, it looks messy. So what we're going to do, if we can't factor it, and I'm going to say that we're not able to factor this one, that doesn't mean we can't factor any cubic ones. We might be able to, but this one's looking a little sketchy. We are going to go ahead and use our graphing calculator. Okay, so I'm going to pull that up right in this space next to it, and hopefully you can see that okay. So I'm going to go to on, I'm going to go to y equals, clear that out, 3x raised to the third power and plus 4x squared minus 7x minus 3. All of that goes into the calculator. I'm going to go ahead and zoom 6 it to see kind of what this looks like right now. And you can see it goes here up, back down again, and back up again. And I'm looking, I want to know when it's less than or equal to 0. So let me just do a quick little sketch over here on this. It's going to do something like this, right? So less than or equal to 0 would be all of this and everything from here on. So I need to find this point, and this point. And those are all zeros on the calculator. And I can do that a couple ways. I can do left bounds, right bounds. And in fact, I'm going to do that right now so you guys can just see it again. So I'm going to find this one 0 right now. Okay. So second trace, number 2 is 0. Left bound, I'm going to pick at -5, which is way over here. And then it looks like -2 is definitely on that side, or at least -1.5 I could do. So we do -1.5, enter. And I honestly, I don't want to guess. I got stuff to do. So here we go. So -2.19 is one of the places it equals 0. And remember, 1e to the -12 is just scientific notation for, hey, that's a 0. So how do I write this over here? I come over to here and I go, I have an open parentheses at -infinity, comma. I know that it can be equal to also, so I can do a bracket. And that number that I put in there, I'm going to write right here. Now, some of you are probably like, hey, Mr. Bells, I know that it doesn't equal -2.19. It's -2.190216. It could go another 50 places. We're just going to round, which I know that means that isn't true, but I want to keep the symbolism for what this point is. So as long as you give me 2, 3, 4 decimal places, whatever makes sense based on that problem, I'm going to call it good. Okay? So then I need to union, and now I need to know where this next branch is. So let's go second trace 0, which is number 2, from -1.5 this time to 0.5. And that should find where it crosses the x-axis back in this range again. I'm going to go ahead and hit enter, and you can see that it's at -0.3716. So I'm going to go ahead and do the brackets, -0.3716. Like I said, I want to give a few different places, so you're not just tracing and guessing on it, but you're giving several of them. Okay. If you want to do to 4, 5, you can do to 4, 5, 2. That's okay. 4, 5, comma. Now I got to find the last one, so second trace, 0. Left bound, I'm going to do it 0.5, and right bound, I'm going to do it 6, and hit enter. And you can see this one's 1.2285. So 1.2285. And that would be right there, the solution for that one. Okay, the last one that we're going to talk about right now is this. This is a projectile motion equation. So again, -16 is gravity's, the force of gravity on Earth, and this is in feet per second per second. This right here, the 165, is the velocity in which the object was shot up at, whether it's a ball or a rocket or whatever it is. And this plus 12 is the initial height. So one of the things we want to do first is be able to get a picture of this going on. So go to your y equals. Let's clear that out and put in -16t squared plus 165 t. In this case, we got to use x's plus 12. And then on my window, I'm going to start at 0 seconds. I'm going to have it go up by 15 seconds. Excuse me, winter cold. I think 165 feet per second is pretty fast, but I don't think it's going to be up in the air for more than 15 seconds. That's a long time. Y max, I'm going to start off with 400 feet, and Y min, I'm going to do -100. Now this is just my guess. I'm going to do my x-res down here at 2. Go ahead and set up your calculator like that 2 to get that shot. And we're going to go ahead and hit graph. And it turns out that it looks pretty darn good, right? But it looks like it goes a little bit higher than 400 feet. So I simply come back down here again and do 500. And I'll probably do -150. Sorry, the lights are on a timer here. There we go. So I just got to come back again and try this here. Okay, so some of the things that I would ask you is how high does it go? Yay, how high does it go? Well, it goes to that height right there, and that would be second trace, and that's number 4 maximum. I can move my cursor over here to the left side of it and hit enter, move my cursor over here to the right side of it and hit enter, and hit enter one more time, and I see that when the time is 5.156 seconds, again, that's an approximation, the height is 437.39 feet. So you're like, well, why are we doing this all of a sudden? Well, maybe I want to know, question, when, or what time, when is the time when the height is greater than 300 feet. So during what time is the ball 300 feet or higher in the air? Well, I could go like this. I could go to my y equals. I go down to here and I put in 300. And then I go ahead and hit graph. And you can see that it's higher from this time right here, whatever that x value is, to this time right here, whatever that x value is. So how do I get that? That's an intersection. So second trace, number 5, intersection, enter, enter, enter. 8.0865 seconds on one boundary. 8.086. I'll go 6 seconds for one. And let's go ahead and do the other boundary. Second trace, number 5, intersection. Just simply move your cursor closer to the other intersection point. 3 enters, and you can see the other time is 2.226. So we go here, 2.226. Okay, so when is it there? Awesome. Between 2.226 seconds and 8.0866 seconds, the ball is greater than 300 feet, or greater than or equal to, honestly. Got to have the little dash there if I use brackets. If not, I would just put curves. Okay. Another question I might ask is this. From 5 to 6 seconds, from 5 to 6 seconds, or let's do this, from 5 to 8 seconds, 5 to 8 seconds. So sorry about that. I want to make sure it doesn't have the vertex in there. From 6 to 8 seconds, what is its average speed? From 68 seconds, what is its average speed? Okay, so what I would have to do is I would have to find out at 6 seconds, how high is it? And at 8 seconds, how high is it? So I'm going to move my calculator like that. Hopefully that's a good visual for you. So I'm going to go to my table setup. I'm going to start it at 6 seconds, and then I'm going to hit second graph to see my table. So at 6 seconds, it's 426 feet in the air. 426 feet. At 8 seconds, I scroll down here, I get 308 feet in the air. 308 feet in the air. So I can tell that this went a total distance of 118 feet in 2 seconds. So 118 feet in 2 seconds on average would be 59 feet per second. So again, kind of looking at ranges of values while we're doing this. Okay, so I hope this was good. I hope this will help you do P7's online stuff really well. And I should be here tomorrow. Again, make sure you have your calculators. Make sure you've checked out all this stuff. I hope this was beneficial. You guys have a great day.